So we got a few panels coming up here, a few discussions, a few topics are very exciting here. Our first one with Oleg Berezin. Oleg has 2 higher education degrees, engineering education in the audiovisual sphere and economic education. He has over 30 years of experience in the film, post-production, and digital cinema technologies. For 5 years, he was simultaneously the chairman of the Association of Cinema Owners and the chairman of the SMPTE section in his country. In 2016, he founded the Higher School of Motion Picture Engineers, which provides educational programs in the field of digital cinema and media over IP for engineers in the film industry, television broadcasting, online services, and Pro AV. And his topic today, implementation of open specifications, NMOS AMWA for discovery, registration, and management connections of digital cinemas. Ladies and gentlemen, Oleg.
Good morning, everyone. I'm going to talk about the benefits of implementing the NMOS AMWA open specifications for discovery, registration, and management connection of digital cinemas. It has been 2.5 decades since the first commercial digital cinema appeared. A combination of various technologies, digital image compression, digital projection, storage, and transmission technologies, which together make up what is known as digital cinema, allow future films to be shown in digital format in theaters with quality comparable of that of traditional 35mm releases. The industry grew rapidly, and by end of 2017, the global cinema theatrical market had almost completely transitioned to digital cinema technologies worldwide. In 2000, at the sunrise of digital cinema, the SMPTE initiated the development of the standards for digital cinema. Through the active work of SMPTE Technology Committee, organized for this purpose, a whole family of SMPTE standards was created, covering almost all aspects of the digital cinema system for requirements for the search material to issues of security and quality of theatrical content demonstration. To date, more than 70 SMPTE documents, including engineering guidelines, recommended practices, registered disclosure documents, and standards of course, have been adopted and published. SMPTE digital cinema standards have been widely implemented and the activity used today by all members of industry, from content and equipment suppliers to digital cinema owners. Meanwhile, in recent years, the audiovisual world have been rapidly moving to IP technology. Data transmission and device management technologies is being implemented across most segments of audiovisual industry, including television broadcasting, media content production, online video services, and Pro AV. But despite the development of digital technologies, digital cinemas continue to operate as standalone entities with limited connectivity to external AP worlds. Let me describe a typical digital cinema system is used in theaters today. In general, digital cinema system for a cinema auditorium consists of the few elements. Firstly, it including a digital projector or direct view display system. This system comprises at least one media block. This is a secure processing block, which houses a security manager responsible for all secure content manipulation and performing content essence description. The security manager oversees the management of security data and content access, ensuring compliance with the policies established by content right holders. The digital cinema system also including playback storage for content for the current show in the cinema, audio devices, and various auxiliary devices to ensure the film demonstration in auditorium. A screen management system is used to manage film demonstration in cinema, auditorium, or in single screen cinema, while a theatrical management system is used to manage film demonstration at the multiplex level. I call them generally as a cinema management system. A key element of the digital cinema system is the right management mechanism. This mechanism is provided, among other things, by a system of digital certificates, which are transmitted as part of key delivery message. The key delivery message contains a symmetric and content encryption key, which is used to describe the content. The symmetric content encryption key is extracted and utilized each time the content is demonstrated, and this key is unique to describe specific content. This symmetric encryption key is transmitted to cinema within a digital certificate, which is set validity period, and then signed with the public key of the specific auditorium media block. This mechanism guarantees that the symmetric encryption key is only acceptable to the relevant cinema in relevant time window. Thus, for access the encrypted content, cinema must provide its media block public keys to the right holder, content provider or laboratory, which is used to encrypt the message, contains the symmetric content key for that auditorium. Studios, distributors, and laboratories create their own databases of such public keys by requesting information from cinemas regarding their auditoriums, capabilities, and certificates of relevant media blocks. The process of obtaining information from cinema is mostly out manually. Forms are completed as a text, spreadsheets, which are usually sent by emails or as various web forms, and are entered to the database of studios, distributors, and laboratories. If a cinema receives content from multiple content providers, it must ensure that information about its cinema equipment is included in each provider's database. This multiple independent database creating a complex and fragmented landscape. When a cinema equipment is changed, for example, by altering the sound system, editing 3D capabilities, or replacing the media block on otherwise, the cinema management should notify all relevant parties, including studios, distributors, laboratories, that supply or may potentially supply content for the cinema about such changes. Typically, it's done also manually by sending emails or making changes to specific data fields in web forms. Obviously, in order to automate the process of registering and management of an array of digital cinema market needs some kind of global database of digital cinema facilities. Such global database collects the list of equipment, the capabilities of cinemas, the location information, and any security-related information from cinemas. The need of such global database has arisen since the emergence of digital cinema market. To optimize information exchange regarding cinemas, their locations, capabilities, serial numbers of media blocks, and so on, the engineering community has made several attempts to develop various components for automated information exchange between cinemas from the one hand and content providers such as studios, distributors, and laboratories on the other hand. One of the first such attempts was the publication of SMPTE standard 130-7 in 2007. This standard defines a facility list message for use in digital cinema system. The facility list message has been designed for deliver digital certificate information between cinema facilities and distributors or content owners. In 2012, one more initiative was attempted. This is the concept of trust device list. The trust device list was intended to contain all information needed by service providers and other ecosystem members to generate key delivery messages to enable the demonstration of digital cinema packages in cinema. Another interesting solution, which is meant to automate the process to obtain the necessary KDMs by cinema theaters, called theater key retrieval. It suggests that digital cinema devices identify URLs from their composition playlist, which are part of the delivering content as digital cinema package, and use these URLs to retrieve the KDMs from the specific website. In 2017, SIMTI had to admit that SIMTI standard 130-7, which specify a facility list message structure for this purpose, has been superseded in practice by ad hoc solutions. For this reason, the SIMTI standard 130-7 has been replaced by completely new SIMTI standard 130-16. This is new standard specifies the extended facility list message instance, which allow information regarding the equipment deployed at the digital cinema facility to be exchanged between parties for the purpose of issuing KDMs and digital cinema packages. Summing up all these attempts, it should be noted that all these initiatives do not define mechanism for searching and registration digital cinemas and global network, establishing connection between the content providers and digital cinemas, although proprietary solutions are activity used for these purposes. Do not define mechanism for updating digital cinema databases. Do not define mechanism for synchronizing database, including eliminated duplicates in database from different vendors. Not define mechanism for applying security TLS connections. And do not imply the introduction of any mechanism for detecting and managing the parameters of network connection of device in the cinema, IP addresses of network interfaces, port numbers, content data formats, and so on. Despite of the existing of extended facility list message, concept of trust device list, the theatrical key retrieval algorithm, and despite the presence of the various proprietary solutions of the market, cinema databases are currently completed by each company manually, using data received from cinemas via traditional emails, text files, and spreadsheet questionnaires. This results in the situation where each content provider has its own database of cinemas it serves. And as previously stated, it is the responsibility of the cinema to ensure that the information about its devices is accurate in all database of companies that supply content to the cinema. But market clearly need a digital cinema facility register. It is needed for all stakeholders in movie theatrical market, cinemas, distributors, studios, laboratories, and authorities. Every movie theatrical market participant is interested in having actual database of digital cinema entities, optimization for discovery and registration digital cinema facilities, optimization for booking films in digital cinemas, and access for any kinds of market players, major or independents. Although the idea of the common global database has been discussed a long time, many questions remain open. Who should maintain such database? How to keep the information about national cinemas in foreign databases? Should it be open or proprietary solution? Who will confirm the reliability of information? What are the mechanisms for discovery and how to keep the database up to date? What are the rules for accepting such databases? To get back the topic of my talk, let's take a break from digital cinemas for now and talk about another word, the word of the AP-based networked media and the AMWA NMOS specifications. NMOS is a family name for specification produced by Advanced Media Workflow Association related to networked media for professional applications. The networked media open specifications, NMOS, provide an open and simple to use vendor agnostic control plane solution that enables interoperability and management of IP connected audio and video devices. In general, the NMOS interface specification describes a set of APIs for the following operations: discovering and registration resources in media system, managing connections of devices, providing an IP-friendly mechanism for carrying time-sensitive information, operating with audio channels within media entity environment, obtain global configuration parameters common for the system for the nodes, accepting or rejecting the API server requests based on the client's authorization, and configuring media parameters for senders using information coming from receivers, and so on. API developed by AMWA widely use open standards such as IETF RFC, open protocols like HTTP and WebSocket, and they use REST approach with simpler messages based on JSON. Today, AMWA NMOS specifications are actively integrated into media devices that are currently available in the professional broadcast and Pro AV markets from wide range of manufacturers worldwide. NMOS specification use the terms node and device. According to the NMOS glossary definition, node is the logistical host for devices, and while a device is a logical block of functionality. These devices may be physical or virtual, for example, software modules or plug-in hardware. And here is an important thought that I would like to express. If we consider the devices of digital cinema system as media devices, their integration into network as networked media allow us to expand the logic of NMOS specification designed to control networked media devices into the world of digital cinema. Each cinema as a digital cinema facility that can house multiple auditoriums logically represent a node, digital cinema facility node, consisting of several devices, digital projectors, each associated with one or more media blocks, playout storages, audio devices, various auxiliary systems, and cinema management system. In this logic, the NMOS specification, at least the specification IS-04, discovery and registration, and specification IS-05, device connection management, can be applied on the two levels of digital cinema facilities. The first level is the inner control plane within the perimeter of digital cinema facility, and second level on the outer control plane for interaction of digital cinema entities with the global digital cinema network. The interaction of devices at the inner level of any media facility within the local media network is described in sufficient details in the both specification IS-4 and IS-5. The specification IS-4 specifies how to register and discover resources in the media system. IS-04 relies on three APIs. Imagine that API node is implemented on each inner node in digital cinema facility and is used to source for resources such as devices, senders, receivers, flows in a particular node within digital cinema facility. Additionally, API node declares and reports the capabilities of each resource included in each node within digital cinema facility. API registration can be implemented on discovery and registration system, such as cinema management system, and provides the registration service for all networked inner nodes within digital cinema facility. And API query is exposed by discovery nodes, such as cinema management system, and allows to query and status of all registered resources within digital cinema facility. If we change our perspective from the inside of single digital cinema facility to considering the network interaction of many digital cinema facilities at the outer control plane, then this outer control plane allows each digital cinema as a digital cinema facility node to communicate with the components of the global digital cinema network. To interact with the global digital cinema network, each digital cinema facility node must have a special gateway, digital cinema facility gate, which ensures the interaction of the digital cinema facility node with the global resources of the network of digital cinema entities. Such network of the digital cinema entities, including the digital cinema facilities, discovery and registration services, registers, content providers, laboratories, studios, distributors, and various authorities represented through their own nodes API. In this case, NMOS specification IS-05, device connection management, can be used to specify how to allow a device, sender or receiver, in the system of networked digital cinema entities to connect with other devices, senders or receiver. For example, imagine that NMOS specification IS-05 allow to provide the standardized mechanism for device management and connection between digital cinema facility node as a receiver and, for example, content provider as a sender of live media stream into digital cinema. Digital cinema facility gate, equipped with a set of necessary APIs, can be implemented as a separate device or a software application in cinema management system. The API described in NMOS specification IS-4 discovery and registration can provide at the outer control plane a uniform mechanism for the following features of the outer control plane: discovering and registration new digital cinemas facilities, notify about new digital facilities, collecting, updating, and providing information about digital cinema facilities capabilities. Several digital cinema discovery and registration services can be geographically distributed and deployed at the national level of each country under the control of some kind of authorities. For example, in France, it can be National Center for Cinemas and Moving Image, CNC, or it can be a national trade association of a country or region, like a National Association of Cinema Owners in USA or UNIC in Europe. Such a mechanism will allow storing commercial information about digital cinemas on the territory of their countries. Data from national digital cinema discovery and registration services can be aggregated by laboratories, studios, and distributors at the user level in their private registers by subscriptions. For digital cinema facility node to search for an available discovery and registration services, the global register, which contain links for obtain number of such services, can be used. This register can be located, for example, at the SIMTI registration authority. Capabilities element described in SIMTI standard 130.16 extended facility list message can serve as the main parameters of capabilities of digital cinema facility nodes. Considering that there are many different players of digital cinema market, a well-developed vendor-agnostic universal and uniform solution is needed for harmonizing interaction of all their players. I convinced that the implementation of open NMOS specification for the discovery, registration, and management of connection for digital cinemas will ensure minimization of manual labor for discovering, registration, and maintenance of up-to-date information of digital cinema facilities and their capabilities, for example, image parameters, audio parameters, screen characteristics, 3D systems, and so on. Optimization of updating cinemas digital certificates. A mechanism for self-registration of cinemas in various databases, which will be collected at Global Digital Cinema Facility Register. Automated provision of KDMs by right holders to the cinema. management of connection between cinemas and their content providers. This includes providing information about the cinema network interfaces for receiving KDMs, digital cinema packages, and media streams of live broadcast. Mechanism for adapting content to the specific requirements of each cinema, such as playback condition, sound level control, screen brightness, audio channel location, and so on. Operational communication with cinemas, for example, to notify them about the critical updates. It is essential to emphasize that the implementation of these specifications does not affect any mechanism to ensuring content protection or security of digital cinema system. And finally, of course, cinemas can continue to operate in their current format, receiving KDMs and showing content as they always have. However, the implementation of open and uniform AMWA NMOS specifications in the cinema industry may form the basis for transition to the next generation of digital cinema 2.0. This is a topic being discussed within professional communities such as Inter-Society Digital Cinema Forum, European Digital Forum, and others. Digital Cinema 2.0 system are likely to provide the new functionality for cinemas, such as new business practices for content distribution in cinema market, moving from the current widespread push model from distributor to cinema to the pull model, selection of content by cinema offered by multiple distributors based on digital contract. Optimization of live content broadcast in cinema. For example, using SDP file to automatically connect and set parameters for receiving media stream content from the provider. Monitoring technologies and feedbacks from the cinemas. Content adaptation for the condition of demonstration or playback. Measurement of quality of service and quality of experience. Automation in situ measurement in cinema. Integration of physical digital cinema facilities with content delivery networks of online streaming platforms. And development of new formats for digital cinema based on object-based media technologies, generative content, personalization of content, and so on. I believe that this way will survive the cinema theatrical experience and cinema theatrical business for the future. Thank you.